Okay, so now we have odd powers. So we have 3 to an odd power. Minus 1 equals 2 to the x. Okay?
So.
And x is odd.
Well, x has to be odd, but that's doesn't. We're gonna ignore the power of 2 for a second. Let's look at odd powers of 3, starting at 3.
3.
27 minus 1 is
26.
26. And if I were able to factor it like I did before into 2 things, what are 2 things that 26 factors into?
It's 13 and 2.
2. Okay. 243 is the next one. This is 3 cubed, so 243 minus 1 is 242, which is
it's 121 times 2, so 11 times. It's 11 squared times
2 times 121. And the next power of 3 above that would be
729 times 3.
Which is it's
3 to the 7th.
2187.
Yeah, 2187.
2186.
So it's 2 times 1000 and 1000 ends.
Yeah. 0.
Okay. What do you notice about when I do this factorization off of odd powers of?
So it's always 2. There's always only 1 2 in it.
Okay. It always seems like there's only 1 2. And it turns out that the polynomial x to the, let's see, 2n, well, let's put it this way, x to the n minus 1 equals x minus 1 times x, all right, the 1 plus x plus x to the n minus 1. Okay. So you're familiar with x squared minus 1, which is x minus 1 times x plus 1.
Yeah.
X cubed minus 1 equals x minus 1 times 1 plus x squared. And x to the 4th minus 1 is going to be x minus 1 times 1 plus x squared plus x cubed. Let's see why that's true. Actually, I'll do it for x to the 5th. Okay?
Okay.
So x to the 5th minus 1, I'm saying is x minus 1 times 1 plus x squared plus x cubed plus x to the 4th. What happens when I multiply these terms out?
So
you get an x
x
times each of these terms.
so
Okay.
that's gonna be x
And
squared.
Minus 1 times each of these terms, or the terms
Or
x squared, x cubed, and x to the 4th
Mhm.
are all gonna subtract away.
Right, and I get a negative 1 minus x squared.
Then you with an x to the 5th and a minus 1.
Okay, so can you at least believe why this happens in general?
Yeah.
yeah.
Okay, but now look at what happens when I have an odd power here. So I'm going to get 3. When this is 3 to an odd power, I'm going to get 3 minus 1 times 1 plus 3 squared plus plus 3 to an even power, some even power 2n, call it.
Alright.
Alright? And I want this to equal 2 to the x. So now I do have a 2 here.
Yeah.
So that's encouraging. But what can we say about this expression here?
Well, we know consecutive powers of 3, at least except for these two. Like if you just sum those two up, or that one, they don't sum to powers of 2.
Well, that's okay. Why?
Well, at least the ones that I can see won't sum to powers of 2. And even if you stop on an even power of 3, that's an odd number.
What is an odd number?
The sum is an odd number.
Why?
Because you have 3 odd numbers added together.
3 odd numbers?
1, 3, 3 squared. That's 3 odd numbers.
Okay, oh, if I stop here, I have 3 odd numbers
Yeah.
added together.
And then you go two more. You're adding an even number to an odd number, which is still an odd number.
Okay.
And you can just keep
And
pairing them and then adding them in
Okay.
up to the 3 to the
Which
2n.
So why is this going to be an odd number if I get an even power here?
Well, because you can group all the powers. You can have a group of 3 and then a bunch of groups of 2, which will all be even, and then except for this odd group, which will be odd.
Okay. Or another way to say that is I have an odd number of terms here.
Yeah.
And these terms themselves are all odd. So we don't know what this number is necessarily. This
It's
is
an
an
odd
odd number.
Which can't be a power of 2.
It won't ever be 2 to the x.
Okay. Pretty cool, huh?
Yeah.
All right, I'm going to show you one last thing on the computer, okay?
Okay.